Hello, my name is Bojan Mitov, the president of Mitov Software, and in this session we'll cover functional programming in Delphi XE5. As Delphi developers, we all know that at the beginning there was Pascal, and it was algorithms plus data structures equals programs. Then in the 90s came the Big Bang, object-oriented programming with Delphi, and it changed algorithms plus objects now equaled programs. The object-oriented programming revolutionized the way we define and work with data in our programs. We still, however, continue to write algorithms largely the same way as we were used to with structural programming. Then a quiet revolution began. With Delphi 2010, for first time, anonymous methods were introduced, and that allowed us to start using extensively functional programming. And this promises to revolutionize the way we write and implement code. Up to now, we have been writing in procedural manner how the code will be executed. That is now slowly getting replaced by declarative notion of writing code, and thus making writing code very similar to the way we define and work with objects. So functional programming allows us to implement programs by simply declaring both the execution and the data structure of our programs. What are the advantages of functional programming? With functional programming, instead of describing how we'll achieve something step by step, we just need to describe what we want to achieve. Functional programming is also very well fit for parallel code execution. It produces significantly shorter code, and it is very easy to maintain and expand the existing code base. We can do functional programming using traditional Delphi or any other procedural or object-oriented language. However, we will face the same type of problems we faced when we were trying to do object-oriented programming with structural languages. It is possible by writing a lot of code, and it practically always will produce worse code than in traditional programming. So obviously it is not a practical solution when using traditional Delphi or object-oriented languages. To demonstrate this, I have created a couple of test projects. In them, I have declared a record with test data, and I have created a small procedure populating list of such records with test data. In my test project, I have declared a generic list of this test type. I am creating instance, populating the test data, and when the form is destroyed, destroying the list. If I want to print all of the data in the list, in traditional procedural or object-oriented programming, I will have to write a loop and tell step by step what needs to be done in order the data to be printed, which is loop through each element of the list and then add this element to my memo. Let's run the project. This is how we program in non-functional programming languages. In my second project, I will do the same. However, I will use traditional object-oriented Delphi to achieve the same following functional programming design. To do this, I have declared my own list. I have declared the procedure in this list for each, which takes as parameter a pointer to a member procedure, taking instance of the generic type of the list. This is effectively a Delphi closure, or event as many people know them. In the implementation of for each, we will loop through the list and we'll call this event. The test code in this case looks very similar. Again, we're creating the list, destroying it, and when we want to print it, instead of saying how we're gonna loop through all of the items, we simply say which method should be called for each item. And we need to implement the method which we will be calling, in this case, print item. We can now run it and see the results. And they're what we expected. We have written a functional program using traditional Delphi methods. Immediately, some issues start to emerge. First, this will work only with member procedures such as print item. What if we want to call a global method? Well, we're out of luck. Furthermore, in case, as with our project 3, we want to do something different than normal printing, as example, print only items with a certain number, we will have to implement a brand new separated method. This is hardly practical and will result in very rapid code bloat and will get out of hand. Let's take a look at what we're trying to achieve here. We're trying to print only items where value 1 of our test record has a value of 7. There are a couple of options we still have in traditional Delphi to solve this problem. Let's explore them. In my next project, we'll try to solve the problem by introducing a member variable for the value we want to print. And then in my print some items function, we'll compare to this member variable. We get the right result, however, we have a lot of issues. First, we are introducing extra member variables which will stay most of the time as part of our object and will serve no purpose other than taking memory out of our application. Number two, which is even bigger problem, is that this code now is not thread safe, because if one thread executes this code and then another thread executes similar code and modifies f value in order to perform a different for each, the two will collide and will get garbage result. So this is a bad solution. There is another solution which is better, and this is to declare a helper class. In this case, for this helper class, we'll have pointer to the form, the value we're searching for, we'll have constructor, member procedure, which we can call, then we'll create instance of that helper class, we'll execute for each, passing the print item procedure as a callback, and finally we'll free the helper class. This works. However, the code significantly increases. It also forces us to remember to add try finally section and free the helper class. We can simplify this somewhat, and I have demonstrated that in my next project. In this case, I still have my helper class, but in this case, it is interfaced object and it implements the helper class interface. The usage is shorter and easier than in the previous example. We'll just create instance of the helper class and we'll pass again the print item method as a callback to for each. This works, but the question becomes, okay, we have introduced so much code, and why we have introduced so much code? Just to use declarative fashion of implementing our code? That sounds hardly worth the effort, and I absolutely agree. So what is the solution? Well, say hello to the anonymous methods introduced in Delphi 2010. They introduced a simple Pascal-like syntax. They're very simple to use, and each of them is equivalent to declaration of interface, class, and creation of instance, all of what we just did. Can you imagine doing all of this with a single line of code? How is this possible? Let's take a look at my next project. In this case, I will have exactly the same list with one single small difference. Instead of declaring tmyproc as procedure of object, I will declare it as reference to procedure. That is all. Now I have prepared my generic list for functional programming using anonymous methods. And how I'm going to use it? Let's take a look. Here is a simple example. In this case, I will call for each, but instead of passing a member function, I will declare anonymous method in place. As you can see, the syntax is practically identical to declaring procedure, except I will not give it a name. So far so good, but what's so impressive about it? It had maybe saved a couple of lines compared to traditional programming. Let's take a look at more advanced options. Remember us trying to print only some of the items? Well, here is an example of doing exactly that. Here we have declared a brand new procedure, and for each element, we will check for the specific condition. Again, you may say, it's hardly impressive. What's so good about that? Well, let's continue with the advantages. We can pass also member functions if we wish, instead of anonymous procedures. We can also pass global functions, such as this one. Again, all of that is great, but the advantages are still relatively small. Let's take a look at my next project. We already know how to perform for each in this fashion, but here is where anonymous methods start to shine. Unlike traditional methods, they have access not only to the parameters that are passed to them, but they have access to pretty much any variable that is available in the function that calls them. So in this case, we can access parameters passed to the function. So if we want to print specific items on a specific memo, we can have a function like this, and we can call it with different parameters, so different items will be printed. Both parameters will be captured and will be used for the printing. Voila! Obviously, anonymous methods are much more powerful and very different than traditional methods. As we mentioned earlier, anonymous methods are equivalent to interface declaration, class declaration, and making instance of that class. So let's see how this actually can help us in our code. Not only we can declare anonymous methods in place, but we can pass them back and forth as parameters. So in this case, we'll call a member function that will return one of two possible anonymous methods. And which one will be returned will be based on flag. It also will capture the parameters passed to our getPrint items inside those anonymous methods. This adds a whole new level of flexibility to our application. We can just call for each, call another member function which will construct the anonymous method we want to execute for each, and then for each we'll execute the newly constructed method. Imagine the amount of code which will be required to write the same thing in traditional Delphi. Well, here, this is all the code we needed to write. Imagine the power you can get. We already saw how I have declared a reference to procedure. What we didn't cover so far is that in addition to introducing anonymous methods in Delphi 2010, Embarcadero has also declared a ready-to-use generic references to procedures and functions. So this code which I did here is absolutely not necessary. We can simply do this, which is equivalent. Here is the Embarcadero declaration of tproc t. They have also declared tfunc, which we can use. If you have been paying attention to the code, you may have noticed that we have totally eliminated the for loop, which is element of traditional procedural programming, but we still do have if statement. An if statement tells the application how to do the things instead of what we need to be done. We can fix that with functional programming by introducing another member method to our list. In this case, it can be called for each where. And it can have two parameters, a procedure to be called for each element matching the condition, and a Boolean function which will indicate whether or not the condition is met. In this case, instead of having if statement, we can simply declare what needs to be done and under what condition it needs to be done. Let's see it working. It obviously works. So far, everything is great, but here is the next question. We can extend our existing classes, but what about classes that are already written in Delphi and don't have functional programming capabilities, or classes written by somebody else which we want to add functional programming capabilities to? One example, obviously, is a form. It has collection of controls, and we would like to access those controls in functional programming fashion. Well, Delphi has a solution for that as well. The class helpers are here to rescue us. They allow extending existing classes with functional programming. Let's take a look. In this case, I have declared a twin control helper, which is a class helper for twin control. And for it, I have declared for each control and control of type. Here is the implementation of the two methods. The first one will execute a proc for all of the controls. The second one will execute a proc only for controls matching specific class. And here is example of how I can set all of the controls on the form to false. Let's take a look. This disabled all of the controls on the form. What about if I want to disable only one type of control? Let's say checkboxes only. Here is example for that. Again, as you can see, instead of telling the application how the thing should be done, we simply say what we want to be done and let it do its job. Furthermore, because this is a helper for twin control, we can execute it for any other control, including other forms. In this case, we create a brand new form and disable all of the buttons on this second form. And here is the code for that. Creating instance of the form, disabling all of the buttons on that other form, and showing that other form. Finally, we have one more trick in our bag. Remember that anonymous methods can be constructed inside another method and returned by it. Here I have created a generic class which has generic method which allows us to call any method with one parameter inside any object. To demonstrate that, in this case, I will call for each control of type button the setTextBuff method, which is a method of tControl, and I will pass hello. So all of the buttons will get their captions set to hello. This was easy, wasn't it? Well, try doing the same thing in conventional Delphi with procedural methods. It surely is going to take more than a single line of code. So the most important lesson of the functional programming up to this point is that this is not so much new way of programming or alternative way of writing code, but this is indeed a new way of thinking how code should be done. Instead of focusing on how the thing should be done, we are focusing more and more on what should be done. This by itself changes completely the way we think about writing code. We already know enough about anonymous methods. Let's take a look at some of the really huge advantages they can bring to our applications. One example is that they can make multi-threading extremely easy and simple. Anybody who has ever written multi-threaded application probably knows the amount of issues and complexity that can emerge there. Anything that can simplify is more than welcome. And anonymous methods and functional programming can make multi-threading really fairly simple. How it can do that? Well, first, it allows for easy synchronization. It allows you to focus on the data flow, not how the synchronization between multiple threads or data exchange will physically happen. It also allows very easy implementation of parallel execution, as example, through anonymous method implementation of parallel loop, as we will see shortly. Let's take a look at some examples. Let's take a look at synchronization. In this demo, I have declared a thread which has pointer to the form in which I will create it. In the constructor, I will assign this member, and inside the execute, we will increment a counter, and we will be sleeping for 1 second, simulating busy process for the thread. Once a second, we will update the form. As you can see, our update of the form follows exactly the sequence of execution inside our loop, and it also captures and passes through all the necessary local or member variables. This way, we can pass between the thread and the main thread through the synchronize method any data that needs to be displayed. Let's run the application. As you can see, synchronizing between the thread itself and the main thread is extremely simple with anonymous methods. This, however, still requires us to declare a new thread, create instance of it, pass pointer to the form, and then implement the execute method. The question is, can we use functional programming to simplify all that? And the answer is yes. Here I have created a thread which takes as parameter in its constructor anonymous method. And then inside its execute, it simply keeps calling that anonymous method until the thread is terminated. Now I can create a thread inside the form constructor, use local variables to access them from inside the thread, and inside the very same thread I can issue synchronization to the main thread and pass data. So the same code we saw earlier now is only this. Impressive, isn't it? We demonstrated synchronization with the main thread. Let's take a look at what we can do when we have multiple threads involved. In this demo, I have 4 threads. Each thread will take some data, will do some simulated processing on that data, and will pass it to the next thread. In essence, creating a queue of threads, each of them simultaneously processing parts of the data. When I click a button, I will take the text from edit box. I will report the event that the button has been clicked, and I will pass this text to the first thread. This thread will sleep for half a second, simulating busy processing. Then it will add a little bit of text and will pass the new text to another thread. The second thread will do the same, taking some time, adding the new text, and pass it to a third thread, and so on and so forth, until we reach the last thread, which after populating everything, will report in the context of the main thread. Let's run the application. If I click the button multiple times, after a while, I'll start getting the results because it takes a while for the text to process those results. And you can see that we have multiple threads running simultaneously. In this case, I have done a slightly modified version of my thread, which instead of taking a single function, has a list of anonymous methods, critical section to protect that list, wake event. Every time we execute one of those anonymous methods, we are adding them to the list, which is guarded by the critical section, and we will signal the event. In our execute loop, we'll enter the critical section, check if there is something waiting to be executed. If so, we'll execute it, and then we'll wait for wake event. So let's look again at the way we are using the threads. As you can see, we have a lot of advantages. Instead of describing how the synchronization between the different threads will be done and how the data will be passed through, we are instead just describing the sequence of how the data should be processed. Thread 1 processes, thread 2 processes, thread 3 processes, thread 4 processes, automatically passing the data between them without the need of using critical sections or any other synchronization. All of that will happen automatically due to the capability of anonymous methods to capture local member variables. Since each member variable is created in the stack when the corresponding function is called, it will not introduce any multi-threading collisions, and it will safely be processed between all of the threads. This significantly reduces the size of the code and improves the performance. In addition, following this code is much easier than following the enormous amount of code necessary to synchronize the work of those 4 threads with traditional programming. Finally, let's take a look how we can implement parallel multi-threaded for loop processing using functional programming in Delphi. In this example, I have an array of data, and inside a loop, I want to start individual threads processing each individual item in the array. We assume that we'll be doing something computationally intensive here. For this, I have created another object called execution. In this object, I will be able to add new anonymous methods for execution. Each one of them will be executed in separated thread, and at the end, I will be able to wait for all of the threads to complete so I can get and display the results. Here is our implementation of the executor. As you can see, it is fairly simple. It has a member class inheriting from thread. It has a queue of threads. Every time I want to start execution, I would be adding one new thread to the list. And when I want to wait for completion, I will simply loop through all of the threads and make sure every single one has been completed. With this simple class, now I can really implement parallel thread execution. Let's run the application. If I click, I'll see that immediately multiple threads are created, and I get some strange and bizarre result. Why I got such a bizarre result? I should have gotten unique value for each of the elements of the array. Instead, in this case, all of them became 0. On other multi-core systems, we will get slightly different random results. The reason for that is one of the limitations of anonymous methods in Delphi. In other languages such as C++, you can specify whether variables available in the context of the function, such as local variables, parameters, or member variables of the class, are captured by context or by value. Unfortunately, in Delphi, everything gets captured by reference. There are, however, solutions for that. Let's take a look at how we can solve this problem. Solution number 1 is displayed right here. We can use a nested function to call execute for our anonymous method. And in the for loop, we'll be calling the nested function. Let's try this solution. As you can see, we got the expected result. This solution, however, is a bit ugly and a bit more difficult to read, since we have to jump back and forth between the for loop and the nested function we are calling. There is, however, alternative solution which is quite clear. Here is a good solution to the problem. Since we can return anonymous methods from inside functions, we can write generic function which will be able to capture any type of context we want. In this case, I have created a generic function which will be able to capture variable of type t. And it is pretty straightforward. We will just create anonymous method. Inside it, we'll call another anonymous method passing the parameter we want to capture by value. This will ensure that this parameter is captured by value instead of by reference. So here is our modified loop. Here we are stating that we want to capture integer variable. We are specifying which variable we want to capture. And here is our procedure that will receive this variable and then we'll use it locally inside the anonymous method. Let's run this application. Here is our result. It is exactly what we were expecting. Finally, let's take a look at what else we can use the anonymous methods for. Since Embarcadero decided to implement anonymous methods as interfaces, this gives us the interesting possibility of implementing smart pointers in Delphi. At the moment, automatic reference counting support is available only for Android and iOS versions of Delphi. And if you are working in Windows or Mac, you still have to delete each object you are creating. Smart pointers automatically will delete any pointer assigned to them whenever there are no more pointers pointing to that object. Let's see how we can implement this functionality with anonymous methods. Since declaration of anonymous method is equivalent of declaration of interface, we can inherit from the method a generic interface for objects. Once when we have created interface, we can declare a class that will implement that interface. We'll declare a field of type T, constructor, which will take parameter of type T and initialize the field. And since anonymous method have a hidden member function called invoke, we can implement this function to return our field. This function is executed anytime somebody tries to execute the anonymous method. Let's take a look at how we can use this. We'll declare smart pointer for tstrings as a local variable, create instance of that smart pointer, and pass it a newly created string list. Once when we have done that, every time we refer to strings, we'll execute the anonymous method, calling implicitly the invoke function, and this will return pointer to our string list. So any member of the tstrings will be accessible. Here we'll add few strings and then we'll display the list. As you can see, we're using it exactly as we would have used the tstrings. At the end, we don't need to free the object since the smart pointer will go out of scope and it being interface will automatically be freed, internally freeing the hosted object. Let's run the application. As you can see, everything works as expected. This concludes our session. My name again is Bojan Mitov, the president of Mitov Software. You can see my email here, mitov@mitov.com. Our website is www.mitov.com. We offer a wide range of products, including Video Lab, video processing library, Audio Lab, audio processing library, Signal Lab, digital signal processing library, Vision Lab, computer vision library, Plot Lab, data visualization library, Instrument Lab, visual instrumentation library, Intelligence Lab, artificial intelligence library. We are nearing the release of Logic Lab, Boolean logic library, Animation Lab, universal animation library. We also offer Visual Live Binding, universal visual live binding library, and OpenWire Studio, a standalone graphical development environment. We also maintain two open source libraries, the OpenWire library and the iGDI Plus library, a Delphi-friendly GDI Plus library. Thank you for listening, and now it's time for questions and answers.